Good morning, children. We will continue our learning about the physical and chemical changes. By now, you all have some idea about the physical changes and chemical changes. Yes, no, children? Now, whenever we say physical change, you all know that that the physical properties of the substance changes, and you know what are the physical properties also. But when we say there is a chemical change in any substance surrounding us, it is due to the chemical reaction. Yes, chemical reaction takes place because the chemical composition of the different substances are different. Yes, so that is why chemical, as per their reactivity, they react and some products are formed. The products are only called as the new substances formed, and they have totally the new property. Uh, New property, they will not have the property of the reactants. So that's why we call them as new substances. And the chemical reaction can be represented using the symbols and formulas, that is called a chemical equation. By now you all know that. So in the previous classes we discussed about some of the examples of chemical reactions. Rusting we discussed, do you remember? And also we discussed about the burning of magnesium and oxygen. When they react, magnesium oxide is produced as an ash, and again the ash is mixed with water, magnesium hydroxide was produced. That's what we discussed in our previous class. So now today's class we will some more examples. We will see how a chemical reaction actually takes place, and what are the products formed, and how are we going to identify it as a chemical reaction. We'll start learning. So today first is we are going to learn about we are going to do a simple experiment as shown in the figure. Copper sulfate solution is taken in a beaker. So in a beaker we will take copper sulfate. So copper sulfate, we are going to take copper sulfate. By now you all know the chemical formula. See, in copper sulfate, it is a compound. In this copper, sulfur and oxygen they are combined and copper sulfate is formed. So in a beaker, as shown in the figure, copper sulfate is taken, and in that solution will be having the bright blue color. As you see, it will have a bright blue color. Copper sulfate crystals also we made, that you remember that. So copper sulfate is having a bright blue color. So blue color solution is taken. In that we have to add few drops of sulfuric acid. Sulfuric acid is added to that, and then you will place a blade like this, a blade, iron, made up of iron blade. You have to keep in that, and you should leave it for some few minutes. So after a few minutes, you can see in the image, slowly the copper sulfate solution will change color. The color will change into green. So why this color change? You know that it is physical change only, but actually what has happened, why the color has changed, that's what we are going to see now. So now copper sulfate solution is taken, and in that we are going to place the iron. Iron is Fe, no children, Fe. Symbol is Fe. So now you will see that why the color has changed, because FeSO4, that is iron sulfate, is formed along with the copper deposit we can see on the nail what we have, the blade what we have kept in the copper sulfate solution. Again I repeat, we are doing a simple activity. Yes children, so we are going to take a beaker. In the beaker, copper sulfate solution, that is CuSO4 solution is taken, and few drops of H2SO4, that is a sulfuric acid, dilute sulfuric acid is being added to that, dilute sulfuric acid. Then we are going to place a blade in this, you are going to place an iron blade in this, and originally the color of the solution will be blue. So after keeping the iron blade in that, after few minutes, that is nearly 20-25 minutes, you can see that color of the liquid changes to green. Color changes from blue to green, it will change. Why? Because the copper sulfate has reacted with the iron, and now the iron sulfate is formed. The solution what is formed is now iron sulfate, and also you can, when you remove the blade, you can see there is a deposit of iron will be there on the copper, will be there on the blade. On the iron you can see the copper deposit. So this is completely a chemical composition. Here see the products, new substances formed are totally they are the new substance, they don't have the property of the copper sulfate or the iron. So this is one of the example of chemical change in which you can see a physical change also, that is the color change. So sometimes some of the reactions have both physical and also chemical. Physically we can see, observe the color change, but actually why the color has changed, it is due to the chemical reaction taken place between the copper sulfate and the iron. Yes children, as shown in the figure. So in this color change, even in our everyday life we find in many things. Yes, so you all know the potato, no? See children, potato, you all know potato. So potato, when we cut and keep, cut the potato and leave it for some time, you can see there is a layer of brownish color forming. So why does it happens? The color change is there, but it is not due to the physical. Physically we can see the color change, but actually the potato is reacting with the oxygen. This is one of the example of oxidation. That is why the color change is happening. Even in brinjal, you cut and keep the brinjal for some time, you will see it is becoming blackish color. That is also one example of oxidation, because the brinjal is reacting with the oxygen in the air, and that is how the color is getting changed. Even apple, you all know, no children, apple. So apple, when you cut and keep for some time, you know that after you are exposed like this, if you open and keep it for some time, you will see that cut apple, you will see the color has changed. Light brown color, it will change, and that is due to the reaction. It's a chemical reaction taking place between the substances in the apple and the oxygen. And to prevent it, you know that when after cutting, you have to keep in the refrigerator, or in the lemon juice they'll keep like that. That is also preventing also is there. That's what we are going to learn step by step. So color change, some of the color changes is not only the physical change, it is due to the chemical reaction taking place also. Just now we have discussed copper sulfate with iron sulfate is formed, and copper is deposited on the iron blade or nail, whatever we keep there. And also in our everyday life, I have shown you apple getting color change after you cut and leave it for some time in the open air. And also just now I showed you potato. These all are examples of chemical reactions taking place surrounding us. And what do you think, these chemical reactions are useful, or is essential or not essential? Yes, so chemical reactions are very, very important. If chemical reactions does not takes place, what will happen, children? Only physical changes are taking place. No chemical changes takes place. Just tell me. Very good. So even photosynthesis will not take place. So when plants are unable to, just think, when plants are unable to make food, the animals and human beings, how we going to get the food? And the food what we eat is also getting changed, and we are getting able to get the energy because chemical reactions takes place. All this, as I told you, we have hydrochloric acid in our stomach. So all these react, and that is how the food is getting digested, and we are able to get the energy for the work what we have to do. So chemical reactions are very important. By now you know that scientists are struggling to find out the medicines for this COVID-19. Yes, so chemical reactions, how the medicines are produced by testing the different chemicals and how they react with each one, and then only the product, the medicine is they are able to invent, and it is useful for the mankind. Like that, many chemical reactions takes place surrounding us. It is very useful also, and due to the chemical reaction, even sometimes it increases the pollution also, like burning of firecrackers and all. It is a chemical reaction. It causes the air pollution. Yes, and that is why we say no, not to. It will create lot of smoke, dust, and all, and that is why it is advised not to burn the firecrackers. Like that, surrounding us, so many chemical reactions are taking place. Most of them are useful, and some of them are not useful also. That all you can identify, and write down. So just now we have discussed about the reaction between copper sulfate and iron. Yes, no children? And now in this color change, you are seen. It's a chemical, it is another experiment which we can do in the lab. And in everyday life, like this color change, I have shown you in the apple and the potato also. Now we'll move on to the next experiment, children. So in the next experiment, we are going to take vinegar. You all might have come across this word vinegar. Yes, so we are going to take, I'll show this activity. Vinegar we will take, and we will add vinegar, few drops of vinegar to the baking soda, children. Baking soda is nothing but sodium hydrogen carbonate, baking soda, and we'll see what are we are going to get. So when vinegar, actually vinegar is a acetic acid. It is one of the acid like hydrochloric acid, sulfuric acid. It is one of the acid, that is the acetic acid. And baking soda, you all know that sodium bicarbonate or sodium hydrogen carbonate, it is sodium hydrogen carbonate. So when both of them react, many new substances will be formed. See, many new substances are formed. Along with that, CO2 will be also formed. Many substances, new substances will be formed, and even it will, the CO2 gas will be evolved. That we can, with by observing only, we can identify. Now I will show this, children. See here, this is the vinegar. So vinegar is very common in a home. We'll use vinegar, right? So I'll take some few, because as you have to see in the lab, we will be with the test tube and all, with the dropper and all. So it is as it is not possible now, you have to observe in the video. I am adding more vinegar so that you can observe. See here, vinegar is being taken in this small bowl. Vinegar is taken, and to this vinegar I am going to add, this is baking soda. Baking soda is nothing but sodium hydrogen carbonate, NaHCO3 we wrote that day. Yes, compound is a compound. Now see, once when I add this baking soda to the vinegar, this is the acetic acid, CH3COOH, its chemical formula is. So when we add that, you will see that carbon dioxide will be evolved as gas. So you can see some, even we can hear some fizzy sound also will come. That's along with the sound, you can see the gas formation. You can observe that. This you can also try, but very carefully you can try without pouring. If baking soda is there in your kitchen and vinegar is there, just a few drops you can add. Now don't take it so much like this. Little you add and you can see. See now when we add, you can see how the gas is coming evolved. See, you can see clearly, children, how the gas is, and you got the fizzy sound. As I had more, I have added more so that you can observe in the video. You can see. So this is due to that sound, and also the gas evolved is nothing but the CO2, children. That is the carbon dioxide. Why this bubbles we have seen, and also some sound was also there, and also there was, you can able to see that gas formation. The gas formed was carbon dioxide. How can we confirm that it is carbon dioxide? There is one test for confirmation of carbon dioxide that can be done only in the lab, children. So we have to connect it, that as shown in the figure, and only the carbon dioxide should be made to pass through the lime waters. You all know lime, no? So like this, lime water should be taken. So lime, I have taken lime and lime water. So we should make lime water, and only the carbon dioxide should be made to pass through this. When only the carbon dioxide is made to pass through this, you will see that will this complete what it is, it will change into a curd-like substance, milky curd-like substance. Only through the cork, tight cork and all, it has to be done. We can see the precipitate will be formed as shown in your this virtual figure. So with that turning of that lime water milky is the confirmation test for the gas evolved is seawater. So what is the confirmation test? Lime water will change milky, like a milky it will change. That is due to the, as we pass only this, that is not possible now. As shown in this figure, virtual figure, you can see that the milky substance is formed because of the CO2 evaluation. But you have seen the CO2 evaluation as when I added the vinegar with the baking soda. So what has happened when vinegar is, that is CH3COOH chemical formula. This is NaHCO3. So when these two compounds are made to react, carbon dioxide is formed along with some other substances. So this is a chemical example of one of the chemical reaction. So in this chemical reaction, what was evolved? Like why we had the previous experiment, you saw that color is getting changed. Here you can see that once some gas is evolved. So during chemical reactions, there will be color change. There will be gas will be evolved, and also sound will be produced. And in the first example was carbon and oxygen. Do you remember? We saw that even there was light is produced, heat is produced. Yes, no, children? So now today we have discussed two experiments. One with copper sulfate and iron. Copper sulfate solution, iron blade. And second one, vinegar and baking soda. Yes, children, in copper sulfate and when we added copper sulfate and iron, we saw that color change. Now here we see that a gas is evolved. Yes, children, so during a chemical reaction, so first of all, so many examples from the beginning I will say. See, first we took C, carbon with O2, CO2, so many carbon monoxide, carbon dioxide, different things were from the wood, charcoal, different things were made. Then we added magnesium with oxygen. We remember magnesium ribbon, and it was white flame and ash was produced. MgO was found as ash. MgO you got as ash. Again what we did, MgO, this magnesium oxide was mixed with water. We saw that magnesium hydroxide is produced. See this experiment we did. Then now today we say CuSO4 plus Fe we did, and we saw that FeSO4 plus Cu, that is copper. Now one more we did, that is the vinegar plus baking soda. Baking soda, we saw that CO2 is evolved. So now all these are examples of chemical reactions. So in all this what we are seeing, see when we take that first wood, this is the wood, wood experiment what we did, wood. So when the solid 2, it was ash was produced, ash will get. Yes children, all the examples. First one was wood with the burning, anything burning, whatever, wherever a candle is burning or a wood is burning, a paper burning, whenever burning means it is a chemical reaction, because oxygen reacts and a new product will be formed. Different types of burning. Burning word when you hear only you can understand it is chemical reaction is taking place there. Then you have seen that CO2 is evolved along with light and heat was also produced. Yes, when we burn a wood, light and heat is produced. Then with the magnesium and oxygen we saw that bright white flame, and along with that ash is produced, that is MgO, and after it reacts we can see that magnesium hydroxide is produced. Then just now we saw that color change in iron sulfate, and then vinegar and baking soda, you saw that CO2 is evolved, that can be confirmed by passing it through the lime water, which will change into milky, that is a confirmation test for CO2. So all these chemical reactions we can infer something. What is that? What is the chemical reaction? First of all we can understand what is the chemical reaction. In all the chemical reactions, so from all these reactions what we can understand, what is generally what is called a chemical change. So in a chemical change, chemical reaction takes place. So in a chemical reaction you all know that chemical composition of the substance changes. Yes, chemical composition is changing and also changes, and new substance is formed, new substances, sometimes one or more are formed. Sometimes gas is evolved. Just now we saw the gas evolved, we saw CO2 getting evolved. Sometimes light heat is produced. Light heat, even sound also we saw, sound is produced, and there may be color change, even the smell also may change. So all these are the things what happens during a one or two or sometimes all also can be seen depending upon the reactants. What two reactants are reacting. All these are about the chemical changes. So chemical changes are the changes in which the chemical composition of the substances changes. New substances are formed. Sometimes gas is evolved, sometimes light, heat, and also sound is produced, and the smell and color of the substance also changes. So this is what about the chemical changes, and many examples have been given to you. I hope now clearly you all know that what are physical changes and what are chemical changes, and also you know that sometimes physical and chemical change together happens. Yes, so children, we discussed about the candle. Yes, when candle is burnt, when you all know that candle, you all know to light up a candle, no children? You know the candle will give out light and heat, no children? Yes, see, I'll draw this is a candle. So whenever candle is you when you lit the candle, you know that this is the flame. So candle is made up of paraffin wax actually. So paraffin wax, if you take the chemical composition of the paraffin wax, it is having carbon and hydrogen. They'll say C25H52 like that. It is made up of carbon and hydrocarbon it is. So this will start when you start, as I told you, burning means it is oxidation. It starts and it will oxygen, it will react, and you know that light is produced. Yes, light is produced, heat is produced. We same experiment we did for the radiation, right, in the heat chapter. Do you remember in the heat chapter? And also heat is produced, light is produced, gas evolved. Yes. So many changes takes place, and also size change. No, size decreases. Size is also getting changed. So this is an example of physical and also chemical change. Physical and chemical change. Yes, like this, some of the reactions are both physical and chemical reaction. Chemical reaction takes place surrounding us. As we discussed, photosynthesis, the main process for the life to sustain on the earth. Plants can prepare the food due to the chemical reaction. It's one of the example of chemical reaction. Food, what we eat, getting digested, the chemical reaction. In the kitchen, cooking is possible. For example, see, this potato is raw potato. Once you cook it, the composition changes and we cannot reverse it back. A new substance is formed. So chemical reactions are part of our life, and most of them are useful and some of them are harmful, like as we discussed, the burning of firecrackers, burning of the different, this garbage burning also. You learn know in the incineration and all how harmful in the 6th classes. So like that, chemical reactions. Now I think you can identify the chemical reaction taking place surrounding you. And one more chemical reaction which you might have observed in your everyday life is rusting. No, children, we discussed about rusting. Yes, like this rusting happens. So this rusting happens on the iron. Iron is a metal. So whenever iron reacts with the oxygen and also with the water, H2O, that is a water vapor in the atmosphere, rusting is happening. That is iron oxide. We already discussed this. Iron oxide is produced. So how can we prevent it? So preventing is possible. See, iron is reacting with O2 plus H2O water, that is, so that iron oxide is formed. Iron oxide, that is the rust. That rust is, when you leave it with rust, it is going to spoil the iron. Iron bars at home, you know that. First we will paint it. So painting and grease also. Greasing or painting will prevent it from getting spoiled. So one more thing to prevent, one more method of preventing the rusting is galvanization. So what is mean by galvanization? Coating zinc metal on iron. So iron is always, it will react and rust is formed. So to prevent it, galvanization can be done. So why galvanization? What they will do in that, they will coat zinc on the iron, and zinc will not, see the reactivity. Zinc will not react, and it will prevent the iron from getting eroded. So that is how, this is one of the method. Like painting is a normal method, you all know that. Even galvanization is also one of the process by which we can prevent rusting. See, ships and all are made up of iron, you all know that. And the ships and salt water, they have to float in the salt water. Salt water will increase the rusting fastly. In salt water is there in the coastal areas. You can ask some of your relatives, whoever is near the coastal areas, the iron things will get rusted very fastly. Why? Because the salt itself will make the rusting process faster. So the same thing happens to the ships in the water also. So that is why every year the maintenance of ship, they will coat it like this. Galvanization will be done, and also some parts will get the same. This will be getting a rusting will be happening, and it will be corroded. So they will be removing and they will be replacing it. So like that, many examples from our everyday life for this rusting and how we are preventing it can be also found out. So by now you all know different chemical reactions, and also one such how to prevent the chemical reaction by another way of another chemical reaction, that is also is given to you. So now you completely read the textbook, whatever is given, observe the pictures, whatever I have activities I have shown and we have discussed, Once again, when you read it, you will be able to understand better, and then you will come to a conclusion how you can identify the changes surrounding you as physical and chemical changes. By now, you all will know the difference between the physical and chemical changes. Every one of you can tell, and with examples, I hope with examples, and some of the changes both take place, like burning of candle, different examples. So you can find out some 10 chemical reaction taking place surrounding you, and you can write in the rough book and keep it ready. Yes, children, by now we have completed learning about physical and chemical changes. Let us see what is there. Some of the questions we did already, which are there at the back. We'll see one or two questions, children. See, when you, after reading the textbook, you can see the questions given at page number 66, and you can try to answer all the questions. See here, children, a fourth question. There is a question. Fourth, when baking soda is mixed with lemon juice, bubbles are formed with the evolution of a gas. What type of change is it they are asking you? Just I want to show that to you so that you can, you will only say what is the gas evolved. See, this is the lemon juice. Okay, children, lemon juice is citric acid. Like before we took a vinegar and baking soda. Vinegar also I said acetic acid. You remember that. Now I am going to add again the baking soda to the lemon juice. Baking soda I am going to add, and you see what is happening. You can observe how the bubbles are formed, and by now you can understand that the gas evolved is, again here also it is CO2, that is carbon dioxide. Yes, children, so this is also a chemical change. This is also a chemical change. I have added lemon juice and baking soda. Yes, so I hope with this you can answer that fourth question, and also you can see the fifth one about the candle burning, and even you can answer the ninth one. So this 4, 5, fourth question, fifth question, and the 9 and 10 question, 4 questions, you try to find out the answers. And again I am saying, read the textbook, and after reading you just try to find out the answers for these 4 questions and be ready for the next class, children. Thank you, children.